Hello, this is the Tepid Coder. I'm going to continue where I left off in the last parsing video, where I was attempting to calculate DPS for some actor within the span of a single fight from an EverQuest log file, as I thought that would be a pretty good example of how to leverage regular expressions in C++. Now in the previous video, I kind of had a brain dead moment, and I was using standard regex search after I confirmed that the pattern matched. I didn't need to do that because in C++ you can actually get the matches when it successfully matches the string. It grabs the capture groups. Some languages match would just like test to see if their expression matches, whereas you have some other function to actually grab the capture groups. So I didn't need to do that, or I moved it, or just the same. The other thing too is, I guess I had kind of forgotten about it, but match expects the entire pattern to match, like the entire string. So I'm passing it this string right here and saying match it against some pattern. This is the pattern. Well, at the end of the string here you say, you know, have a word character, right? Who's the actor? You, or so-and-so. They slash someone, they hit someone, they pinch them, they bite them, whatever. That's the next word. And it says anything that's not a number. So it's going to move forward from here up to it, to the point it has a number right here. And then it's going to say, while it's a number, keep going forward until it's not a number. So we're getting this 13. But then there's some extra junk at the end of this, so it wasn't matching. So I had to do dot asterisk, which means dot is any character, asterisk 0 more. The thing I could have done is if I just use search, it basically searches for a substring in this that matches. So it'll kind of seek through the string till it finds something that matches this pattern. And for stuff after, fine, no one cares. If the stuff before it, doesn't matter. It just finds that substring and uses that. So let's just show that working real quick without the dot asterisk. Let's say G++, test.cp out. Oops. Output is going to be test, and then we're going to have standard equals C++. Let's do 20 because I'm going to have to use format later. Okay, run it, and you can see it still works. I'm going to keep it as match, just because I'm only going to be matching one line at a time and not really searching through anything. Yeah, so. In some languages, you'd actually have to put specifically that you want the string to start with that, with some kind of a character that shows that. So like, if you do a caret at the very beginning of the regular expression, it means it has to start with this. And if you do a $sign at the end of the regular expression, it means it has to end with that character. But C++ match, I guess, is a bit different, and it just already assumes that you want that. Maybe search would be that way, though. I can tinker with that or something, but that's not really relevant to the thing I want to show here. So what we have at this point, just to go back here for a second, is we have the day of the month that this event happened, we have the hour, minute, and second that it happened, we have the person who performed the action, what the action was they performed, and how much damage it dealt. So that's good, because now we can say things like, if we know when the fight started, when was that timestamp? And when the fight ended, when was that timestamp? And we can get the number of seconds that elapsed between the two to calculate the total number of seconds of the fight. And then if we could take the total number of damage points that occurred in that time frame for some actor, we can divide that by the total number of elapsed seconds to get the damage per second. We have total damage divided by number of seconds equals damage per second. So anyway, in order to do that kind of calculation where we're subtracting these date times, we're going to need to do some messing around with some objects. Now, there are things like standard chrono we can use. We can use some functions from that to actually get the elapsed seconds between two time points, but constructing a time point actually isn't fully fleshed out in C++ at this point, so you actually have to use some C functions from ctime. And personally, I find the chrono functions, since they're not cross-platform in all manners, to be not only unwieldy, hard to remember, hard to use, confusing, but suboptimal. I find the C way to be better. Now I'm going to probably splice in a little chunk of me using both to show how they both work. But then when I actually add this to the parser, I'm probably not going to use this. I haven't decided yet. I'll probably just do it the ctime way, and you'll see why. But let's just prepare this project first. I'm going to include format. I'm going to include stream. I'm going to include iterator. This way I can basically do something like standard v format 2. There's no underscore here either. And then whatever the output stream iterator is, right? So let's just get that set up real quick. So I'm going to say standard ostream iterator of type character. I'll call it cout, which is going to come from standard cout. That's going to let me do standard v format 2 cout. You know, this is only a test, let's say, and then standard make format args. I'll say test. All right. We'll confirm that works real quick. Okay. Ostream iterator. What did I type? Iterator, apparently. Iterator. Iterator. Okay. Okay. This is only a test. Let's go over the time stuff now. Alright, so I'm just going to take what I need from here, and I'm going to put it in a new file so I can show off the date stuff I was talking about. So I'm going to say time.cp, and let's start actually getting stuff into what's called a standard chrono time point. So I'm going to get rid of this here for later. So what I want ultimately is going to be a standard chrono system clock, or you could also use steady clock, time point. So TP now, let's say. We could also have like a TP then or something. You can subtract 2 time points. Whatever the case may be. So in order to get this from some known timestamp, I'm going to have to be a bit crafty and go from C to C++ stuff. So C has struct tm. Okay, let's call it tm timestamp. Okay, initialize it to 0 or something. If you actually want to use 2 time points, you can actually construct a timestamp by filling out some of its arguments. Let's say, remember, I mean, timestamp dot, it's going to be tm year. That's going to be the number of years since 1900. So if I want to use the year 2000, it would be 2000 minus 1900. Then we have tm timestamp tm mon for month equals, it's going to be the month minus 1. It's 0 based. So right now it's the 8th month for me, so I'm going to say that minus 1. It's going to be the 7th month. Or month index 7, you could say. So tm timestamp dot, I'm going to paste this a few times, so typing that out. Okay, tm is going to be m day for month day equals, and this is just the day of the month, it's 1 based here, so it's at 1. So for me the day is 16th, okay, tm, we're going to do hour equals, right now for me it is 3 p.m., so it's 12 plus 3 military time. Tm min equals, it's going to be 0359. Right now it is 336 for me, so 36. Okay, and the second I don't know, I'm just going to say second is at 0. Okay, and then we have one more thing, which is tm is dst, is daylight savings time. I put -1, so it tries to calculate that for me automatically. Okay, now what I can do is I can convert that to what's called a time t structure. Also comes from C. So I'm going to say tt, we'll say then, should I call it, I was going to call it timestamp for now. So tt timestamp for time t timestamp equals, I'm going to do mk time, make time, and I'm going to grab that from the tm timestamp, pass it by reference. So I'm converting this structure into a time t I can work with for formatting and whatnot. Now, I can convert that into this standard chrono system clock time point and do the calculation for the elapsed seconds that way. So I'm just going to show how you can do that real quick. So standard chrono system, apparently, system clock. I'm going to do from time t, that's what it is. And I just stick a time t in here, so it's going to be the, what do I call it, tt timestamp. Okay, and now what I can do is get the duration in seconds, the elapsed time. So I'm going to call it standard chrono duration using a double. Okay, call it dur elapsed seconds equals, we're going to do standard chrono duration cast, and we're using seconds, so standard chrono seconds. I could also do milliseconds or microseconds or nanoseconds. It's going to be different on the platform what's supported, but you can do that. In this case I'm doing seconds. I'm going to say, let's see, TP now minus TP then or something. So we have, what do I call this? TP now, yep. Which is not actually right. This should be TP then. Let's actually make it TP now. I should be able to do standard chrono, system clock, and then just now. And that'll construct a time point from the current timestamp. Current timestamp. Okay. Timestamp from explicitly defined date time. Okay, so now we have some kind of thing that we can use to get the elapsed number of seconds. And what we do with that is we actually have to use a method inside of this object that was returned called count, which will count the elapsed seconds in doubles. So let's do that real quick. So it's going to be duration elapsed seconds dot count. Let's say elapsed seconds. Okay. Over here I'm going to say g++, let's say dash standard equals c++ 20 because we're formatting. We're going to say, nope, not test, time.cp, output is time. Looks like I messed up somewhere. So see how I didn't include IOStream, that would do it. IOStream. Okay. Try it again. So, ctime clock is not declared. Wouldn't expect it to be. System clock. Okay. Okay. Error TP now is not declared in the scope on line 29, so no. 29. So where did I define TP now? Ah, right. Standard chrono system clock time point TP equals that. This is TP now equals that. Okay. This is quite verbose. Okay, I got a return from main. Sure. Fair enough. Now see it working. That's how many seconds were elapsed apparently. Let's take this number into calculator. Let's paste it here. Let's say there's 60 seconds per minute. There's 60 minutes per hour. There's 24 hours per day. And let's say there's 365.25 every 4 years is an extra day. Days per year. And yeah, that looks about right. It's about 24 years. Now, remember, I set it to the same month, the same day, the same hour, the same second as I was typing that. So all that's really changed here is maybe some seconds have elapsed and a couple minutes. Not a whole hour, obviously. It hasn't been that long since I started typing that and talking afterwards. So I'm willing to believe that this is the correct number of elapsed seconds. I could go more granular and test that and show it off, but I think the point should be well taken. Now, instead of doing all of this standard duration, or standard chrono duration of type double, whatever, equals standard chrono duration cast into seconds from the endpoint minus the start point, all this stuff, like this is just a lot to type. What I could do instead here is I could get the current timestamp a different way. It's a little bit easier. I'm going to say TT now, it comes from it's a time T type. It's going to equal, I'm going to say time apparently, null pointer. This is going to give me the current time as a time T, which is kind of like standard chrono system clock or steady clock now, right? It's kind of like that, but for time T. And then what I could do is I could say standard, I'm actually going to just copy this to be quicker. Let's copy all of this. Okay. I could just use that instead and say, what is it, difftime? It's difftime. And it would be TT now minus TT, what do I call it, timestamp? Timestamp. You can see I got that over here somewhere. Right here. So I made the time T, I converted that into a, or sorry, I made the TM structure, filled it, and I converted that into a time T with make time. And over here I'm just creating a time T from time null pointer. I can say diff time, that's going to give me the difference in seconds. Okay. So let's give that a try. See what we get. Oh, I don't know why I put it. It's this comma that, it's subtracting them. Okay. There we go. You can see it gives me the same value. And technically, I should have to do like 0 points of precision, so it'll round to the nearest second. So let's actually do that, because it could have stuck that in scientific notation if it wanted to. Yeah, anyway. So this method right here, I think is what I want to use. This is just so much easier. I can even make a function, which I'm going to do real quick, to just convert a year, month, day, hour, minute, second into a TM structure. So let's say, I don't know, create TM from date time. I want to call it that? I don't know. I'll just say create date time. And the fact that it returns a struct TM should be enough to obviate any ambiguity that would otherwise be there. So let's return tt timestamp. In fact, I could just return the make time right here. I'll do that. Return. And I'm actually getting a time t from this in that case. So time t. Yeah, I'm going to say unit 16t, UI 16 year. That'll hold up to the year 65,535, which I'll be dead way before we reach that year, so I'm fine with that. Unit 8t, you'll say UI 8 month. Start pasting that because I'm using that a lot. So month, day. And then we're going to say, I mean, I could say month, day because it's not like the weekday, for example. Hour, let's say minute, we're going to say second. Okay. Cool. So now I'm going to start replacing some stuff here. I'm going to say UI 16 year minus 800. Let's say UI 8 month minus 1 and UI 8 hour, and then wait, what am I saying? That's a day. Okay. And then we have UI 8 hour, which needs to be in military time. Let's say military hour. Military hour. Okay, now we have UI 8, it's going to be minute, UI 8 second, and just let it calculate always for us. Okay. Cool. So now what we have here is a time t. So time t, I'm going to say tt timestamp equals create date time. I'm going to say 2020, for example. And I'll say same month as you have now, 16. Same day I have right now. It's going to be 8:16, yeah. And then we're going to do the hour is 12 plus 3. We're 45 minutes in. And then we're at 0 seconds, let's say, because I don't know. So I'll try that, and that should work the same. Okay. Wait, day was not declared in the scope, right? It's month day. As opposed to weekday. Okay. And it works just the same. Alright. So that's nice. Now before I might have put something else like the year 2020, or just the year 2000. I don't remember. Let's try 2000. Because that number looked different to me. It's kind of arbitrary anyway, but yeah. Yeah, I did put 2000 earlier. That's right, it was 24 years. I used the calculator. Okay, anyway. So at this point, we're pretty well set to basically just create a time t with this out of a timestamp that we parsed from the log file, and with another timestamp that we parsed from the log file, and then subtract the two with just like difftime. So in the next episode, I'm going to be doing that, and I'm also going to be figuring out when a fight started and determining when it ended. So if you like this video, give it a thumbs up, consider subscribing for more content like it, and I will catch you guys in the next one. Leave some comments if you have any. Catch you later.